Welcome to this tutorial on damage stability. Tutorial number 640 focuses on floodable lengths. So the floodable lengths command is what we'll use today. We're going to talk about permeabilities for those, bulkheads, and the number of compartments. Now, first a quick disclaimer. This presentation is for instruction purposes only. It is not to be used in engineering for construction, and I am not a representative of Creative Systems. This is unofficial training only, based upon my own personal knowledge and experience. For the official training, you can contact Creative Systems directly. I highly recommend it. It's very useful. So, floodable lengths. What are they? They are a preliminary check on damage survival. They're used at the initial concept design stage because they're faster than a full damage stability analysis. It does not check stability. It only checks that you have sufficient buoyancy to sustain damage and stop from sinking straight to the bottom. So there's still the possibility that your ship will flip over, but it will still be floating, is the requirement that floodable lengths checks for. And the way it checks that is that there is no margin line submersion, and it does allow you to consider different permeabilities of each compartment. And then you can also take those floodable length curves and compare them against your current compartment lengths. Okay, so how does the command work? To generate the floodable length curves, first thing, you have to have two things. You need to have a margin line set, and you need to have a VCG set. The VCG is necessary so it can calculate the correct trim of the vessel. Okay, so the GHS command is FL, which stands for floodable lengths, and then your list of permeabilities. And it will create one floodable length curve for each permeability that you provide. And these are decimal values, so a value of 1 is 100% permeable, meaning that 100% of the space can be filled with water, whereas a value of 0.5 would only be 50% permeable, so only 50% of a compartment could be filled with water. The nice part here about the floodable length curves that I also have to define for you is you don't need to actually have your compartments defined in the GHS model yet. You just need to have a hull definition. And that's why we're doing it at the preliminary stage, where you might know what your hull looks like, but you probably don't know what your internal compartmentation is. And so the floodable lengths command helps you figure that out. So here's a couple examples. You can see FL of 0.95, 0.85, and 0.6. So it will give us 3 curves. You can also do it with a dotted list. So 0.95, 0.90, and this is going to keep going. So 0.85, 0.80, 0.75, 0.70, 0.65, 0.60. So both of those options work. Now the full command sequence for how to use floodable lengths. First you read in your geometry file. Then we start a report. The report's going to be really handy to get the graph. You set your VCG. You set your draft. We run the floodable lengths command, and if you don't provide any permeabilities, it will default to 0.95. And then we turn off the report, and we quit GHS. And out of all of that, you'll get in your report a graph that looks something like this. To start with, all you'll have are these, the floodable length curves, right here. Notice that in this case, there are 3 of them. So 3 different permeabilities. Now, let's talk about showing bulkheads. So let's say you've run your floodable lengths the first time. Now you have a good idea of what your compartment lengths are, and you'd like to show them to prove that they meet floodable lengths. The way they're shown are as TPs on the graph. And all those TPs should be below the floodable length curve. And they should be below specifically the permeability that's assigned to each compartment. Usually that's based upon regulations. Now the way you add that into the GHS command is you still run the FL command with a list of permeabilities, but now we have this bulkhead option. and that is the list of bulkhead locations. Now notice here, the list must be in sequence of increasing longitudinal position. Okay, I'll say that one again. It's not just a random list. You have to give your positions in sequence because you're giving the positions of the bulkheads. And so GHS is comparing between positions to find your actual compartment lengths. So here's an example here where we've done floodable lengths. I've provided 2 permeabilities, and then the bulkhead option where I've listed 1, 2, 3, 4, 5 bulkheads. Now notice there that your bulkhead locations, they don't have to be regularly spaced, but they do have to be in sequence of increasing X. And when you do that command, you're going to get a graph that looks like this. So now we're going to get our floodable length graphs right here on the top. Oh, that's very nice. And we're going to get these TPs down here on the bottom. And that's going to tell us the other part that we need to see. Pretty handy. Now the next thing you can do is you can do multiple compartments. So some vessels will require survival of the vessel for more than 1 compartment's worth of damage. The way that the GHS will show that is as stacked TPs. So you'll see 1 TP, the next one beside it, and then you'll see a large TP that's the combination of the two. The way you modify your GHS command is with, again, the floodable lengths command, but we add on the NC, and N is the number of compartments. So floodable lengths of 0.95. Here's my permeabilities. I've defined my bulkhead locations, and now I'm adding on how many compartments. And that's how many compartments will be considered flooded at any one time. And so the way GHS would interpret that is it's going to first check flooding of 1, 2, 3, 4, each one of those individually. It's then going to check 2 at a time. So it'll go through those. So that's that's 4 combinations. And then it's going to check 3 at a time. So it'll go through these 3, and then it'll go through these 3, and then it will go through these 3. That's 3 combinations. And all of that will get printed into the TPs. Okay, so go ahead and give this a try. Homework number 641. I'd like you to run floodable lengths on the barge model, set it at a VCG of 5 meters, draft of 4 meters, and include 3 specific permeabilities of 0.95, 0.85, and 0.60. Then what I'd like you to do is repeat that command, but now with the floodable lengths with the bulkheads included. Excuse me. So number of compartments is just 1. And then find the bulkhead locations. There's a general arrangement drawing provided. So a bulkhead is anything that segments off the entire section of the hull. Okay, so it's the entire transverse length of the hull. And then repeat that floodable lengths exercise again with bulkheads, but this time consider it with 2 compartments. And just a fair warning, I don't guarantee that the ship will pass floodable lengths. You just have to produce the output. Okay, thank you very much for watching. I hope you found the video informative. You can find the homework files and other videos like this on dmsonline.us. Thanks very much.
Thanks for watching. I hope you liked it. Hey, did you know that there is a magic button down below? Click the like button or even the subscribe button, and I will make more videos for you.